My name is Justin Graham, and I run product management for the AWS Marketplace. And I'm joined by Aaron Rosenbaum, Vice President of Product Strategy from MarkLogic, and Anand Vaghela, who is Senior Product Manager at FileMaker Cloud. And we're going to talk to you for the next hour or so around relational and non-relational databases on AWS, and some customer case studies on how to use some of those solutions in conjunction with some of our great solutions from partners to solve some of your issues or use cases using those things. And lastly, thank you for taking your lunch hour, so hopefully you got some food either right before this or you're planning on getting some food right after this. So first, want to quickly cover what you can expect to gather out of this session. So we're first going to talk through database and data management things that are available from AWS broadly as AWS services, but also available through the AWS Marketplace in terms of third-party solutions that can be used in conjunction with AWS services. Second, we're going to bring Aaron up to talk to you about a customer case study from NBC with MarkLogic, also in conjunction with AWS services, and help you walk through and think about how scaling architecture and operational decisions were made in a use case with NBC. And then we're going to finish up with Anand from FileMaker coming up to talk to you about a similar set of use cases from an automotive company in conjunction with FileMaker Cloud, in conjunction with AWS services, to cover a different set of scaling issues and decisions using those solutions. And then we'll take Q&A. Aaron and Anand will be here for Q&A for you to ask questions after the session. So first, how many folks have heard of the AWS Marketplace? Okay, excellent. How many of you that said you've heard of it have used it in any way, shape, or form? Okay, excellent. So quick recap for those who didn't raise their hand. The AWS Marketplace is a third-party marketplace for enterprise software and infrastructure software that runs on AWS that you can subscribe to and deploy directly to your AWS account using EC2. And as of 2 weeks ago, you can also subscribe to and provision software as a service with over 30 offerings available at this point. From a database and data management perspective, the AWS Marketplace has over 300 available listings of third-party database and data management solutions that run on AWS. And MarkLogic and FileMaker are examples of those. In terms of other solutions, we have a total of over 3,500 products and listings available on the AWS Marketplace, covering everything from database, data management, BI, security, and other categories. We have 35 total. We also offer a unique pay-as-you-go subscription, so you don't actually incur any charges until you actually run the software. And we also, some vendors also offer annual purchase options as well, so you can subscribe for a year if you'd like to, and some flexible metering and elastic metering based on hours of software running or number of users, depending on the solution that is available. And lastly, much like the rest of the AWS services that you use, anything that you use from Marketplace shows up on your AWS bill in the same way that your usage of EC2, RDS, S3, or any other service would show up. So just a quick overview for those of you who have not, and for those of you who are continuing to use it, thank you. Next, in terms of specific database offerings that are offered by AWS, we always like to ground everybody in some of the use cases and solutions that we have, because people have different needs and different uses. So if you're looking for a relational database managed on AWS, RDS is the solution that you're looking for, and you can use RDS in conjunction with MySQL, Oracle, SQL Server, Postgres, and others. Or you can use Amazon Aurora to solve your relational database needs. Next, if you're looking for non-relational database, DynamoDB is the solution for you, which is managed NoSQL on AWS as an AWS service. Next, if you're looking for in-memory cache that is easy, Elasticache is this AWS solution that you're looking for, which is an in-memory cache cloud service that you can use and subscribe to. And then if you're looking for a data warehousing solution, Redshift is the solution that will best meet your needs from a data warehousing perspective. And then lastly, if you want to manage and run your own database, you can grab database solutions off of the AWS Marketplace. We have a number of those solutions that you can run and manage on your own, but you can also look through the community AMI inside of the EC2 console to find some solutions there, or you can bring your own solution into AWS that you can manage and run yourself. And then lastly, within the AWS Marketplace, we have a number of subcategories in the database and data management area that are available for you to use. So on the right-hand side are ones that are what we consider BI and big data category solutions, and on the left, you have database solutions and data management solutions in terms of subcategories. So breaking down those over 300 listings into other offerings that you can subscribe to. So without further ado, I'll bring up Aaron Rosenbaum, Vice President of Product Strategy for MarkLogic, to talk you through a unique case study with NBC and MarkLogic. Aaron?
Thank you. So we're going to get technical pretty soon, but I want to first establish some context for the sort of interesting operations DevOps story. So back in February last year, Saturday Night Live had their 40th anniversary special. It was expected to be a large event. It turned out it was the largest non-broadcast viewership, non-sports broadcast viewership that had been since the finale of Friends. And to go along with that special, they were going to launch an app. And I think everyone, let me just say, on a scale, let's show hands, on a scale of 0 to 10, with 0 being awful and 10 being wonderful, who was an experience of an app to support a large live broadcast event? I'm sure whether it's World Cup, the Olympics, entertainment, anyone had a great experience? It's a really tough problem operationally. You have an event, an app, you have a rapid team, you usually have a short time frame, you don't have an extent operational practices. Often there's no soft launch. You have massive traffic right at the get-go. And from a functionality standpoint, there's a really great challenge, which is, do you do something flat and uninteresting but reliable, or do you do something interesting that might prove challenging operationally on a very, very public stage? The mandate from the team and the business leaders at NBC was it had to be compelling and interesting. There are 5,500 clips of SNL content going back 40 years. This is valuable content. It had been out for interactive usage before. There was apps before. But people just would skid across the top. They'd view 3, 4, 5 clips and never pay attention again. It was a boring user experience. The mandate to the team was to turn these bite-sized experiences into a meal, to build binge-watching behaviors in this second screen app that they'd only had on drama. That was a pretty big challenge. The second was it had to not fail. That was not an option. Who remembers million-second quiz? Anyone remember that? Ryan Seacrest had to apologize on live TV on the second night of it about the interactive experience. So when we got involved with this project, that head of digital was gone, and a new person had come in to take his place, had a few months to get it up and running. And decided that the core of this would be a real-time dynamic recommendation engine that would be responsive to everything that a customer user skipped over or watched, and then build the next set of experiences. Had to be massively scalable. They were going to launch the app. They gave them little soft launch. They launched the app on Thursday. It was featured in the App Store on Friday. It hit #1 in the App Store on Saturday. The special ran on Sunday to 20 million viewers. It was promoted on SNL. It was promoted on social media. It was pretty big. So they leveraged a lot of what they knew, but there was still this new recommendation engine. So what was behind it? Sort of several features. You have this sort of user profile, tracking watch events, search that was contextual to what someone had watched before, and this recommendation package. And it was all sitting on top of the repository of the watch events and this rich semantic graph. So you could search for cheerleaders, and you're going to get content with Will Ferrell, who one of his characters is in Cheerleader. And they had just a massive set of librarians sort of preparing all this content before. So they had come to us because we had done this together with AWS for a lot of media companies. We're sort of a standard for metadata management in media firming, content distribution. We've run iPlayer for BBC, a bunch of metadata repositories, the Wall Street Journal, Dow Jones. You've absolutely used services that have leveraged MarkLogic in the last day, even if you don't know it. We're pretty ubiquitous. We also do work outside of media and entertainment in defense, intelligence, finance. We've been on AWS, and partnered with AWS since EC2 was in beta. We've had production customers on beta. We are NoSQL, but we're scale out and ACID, have pretty deep functionality. Yes, you can be ACID and scale out. People bring their own licenses. They also just get them on the marketplace now that we've gotten rid of DevPay. So there are a couple of things I want to introduce architecturally before we drill down. The first is when we think about database, we usually think about sort of app services up above on a separate tier and sort of orchestration. There is a fair amount of orchestration done by MarkLogic itself. There is a delegation of those roles by thread. They can run on the same box or separate boxes, but it's a pretty compact stack in terms of persistence and application services. HTTP out this top, you build app services at that level. The second is it is scale out, right? You're going to add nodes to gain capacity, to gain distribution, right? And this is not necessarily normal sort of behavior. So generically, there are 4 major ways we scale out a MarkLogic cluster. And this is on AWS or not on AWS. It's a shared nothing system. We run exceptionally well on AWS, especially now with GP2 and high throughput storage. First, of course, you can scale vertically. Right? You can do a lot with those X1 instances. But you can also scale horizontally. And you can scale horizontally just at what we call the evaluator nodes, which is just running MarkLogic without persistence attached to it, but being part of the cluster. So it can take queries, dispatch, do orchestration, run app services, and most importantly, cache. Or you can also scale out data nodes. Scaling out data nodes is much more expensive than evaluator nodes. You've got to move data around. And lastly, you can also just replicate entire clusters, right? If you've got a highly asymmetric load, lots of readers, relatively small number of updates, you can live with some consistency lag. You can do that replicators. So when we look at these different issues, we look, what are the metrics and what are the behaviors? What are the application behaviors which we're going to scale on and making sure that those align to our expected user behaviors is sort of key. So when we think about eNodes and MarkLogic, it's search, type ahead, cache results, semantic joins, interactions that cross multiple nodes, going to consume those CPU cycles, and can live on ephemeral. They're simple to add. They can be added. There's no data. Basically, spin it up, join the cluster, get the users off. You don't want to slam them down. You'd rather wean them off and leave the cluster. D nodes are more typically added for longer-term expansion. But it's not just IOPS that impact the persistence, right? You've got network bandwidth issues, limitations on each node. There can be definitely scenarios in which scale out is cheaper on the persistence layer than scale up. Most of the time, unless you've pegged the CPU, unless you're totally out of RAM, it's pretty expensive. And lastly, I'll throw up this example. This is Dow Jones uses Replica clusters to run their news alerting service. So they have hundreds of thousands of people waiting to get alerts to the Factiva service or through Flipboard or through an automated trading system. And the queries are far more queries than there are records, right? They might run 50,000 updates an hour. So they use these and they move up and down with the news cycles. And they cycle them down on the weekend and cycle them up. It's also interesting, it's a hybrid app. So let's talk about SNL and talk about the choices that they made and how they were able to manage the scale. So I think at the top level, right, they need to leverage known existing design patterns, right? When we've got parts of the load that are known, we're going to do that. So global DNS is your first line of defense, right? You must have a way to protect against DDoS. You must have that sort of failover router of last resort, and that's the intersection point for CDN. And NBC, Comcast owns a CDN from Comcast Digital, MPX, so they do the rights management, making sure the right stuff appears in the right country, variable bitrate streaming, all of that sort of stuff. That is considered a generally known, understood problem, right? And that wasn't a point of innovation. Point of innovation was sort of underneath, the recommendation engine. The next sort of interesting architectural decision they made, this was a US broadcast. It was not simulcast overseas. So they decided to go with one region, 3 AZs. This is an often common point of discussion for many of our large media customers. Do I run in multiple AZs? Do I run in single AZ? And there's a lot of run multiple regions. There's a lot of complexity for running multi-region. It is absolutely more resilient. But what does the failover take? How much complexity does it introduce, particularly at the DNS level, right? Because you can't, if you've got one region, you can have one advertisement to the VPC router. If you've got 2 regions, you've got issues. So they made a decision to go one region. The latency, East Coast to West Coast, was fine, met their needs. But they wanted resiliency. It would not be acceptable, even in a rare, AZs go down very rarely these days, but it would not have been acceptable, especially during the event. So we went 3 AZs. So there was one VPC that encompassed all the services within those. It was sort of very tight. There wasn't a lot of interaction. It's basically user-level services up above. HA proxy was used within then each AZ. It's an alternative. People have back and forth TLB, but it can be a little easier to scale. You get to choose your instance types and more flexibly you can put it on a bigger box. And that directed traffic either to Node.js, which was handling sort of basic session, not massive orchestration, but sort of basic session maintenance. The reason was wanted to keep the personalization, search, user profile, user event, all those activities keep all of the calls idempotent, service-oriented. Really wanted to keep basic state management as lightweight as possible because we have a consistent view at the database level. And so the packages, we have sort of basic session handling. Some events would go straight from the database cluster back through to the user. Some would go through Node.js. Inside of the database cluster, then that actually spanned all three AZs, right? So each within, we were talking, once you're attached and directed to an AZ, you'd stay within that for E nodes, but then it would span all of the D nodes. So that was our failover level that gave all the control there. This one then other, I think, interesting lesson, we'll talk about a little more later, was how they mitigated risk. We talked about, this is a mega event, right? We got 22 million viewers night of. We're going from nothing to, potentially hundreds of thousands concurrent queries, right? How are we gonna mitigate that risk? So they had tests and more tests and challenge scope and all the sort of basic hygiene that we'd expect in ops, but we still need contingency plans. The team made sure that each piece of the user experience not fall off a cliff, but degraded gracefully. So an example of that would say, in the event of write unavailability, right? I'm in the middle of a failover event, or there's a DNS response failure, or ELB failure, and I can't get to the database to do the write. What am I gonna do? At the app tier, they went through the write to SQS. So the next set of responses for what you should watch, you should play with the app. It comes back and these events are all happening within 50, 100 milliseconds, talking about in terms of writing your answers, getting back recommendations. So we degrade the next set of recommendations, but the ones a second later wouldn't be degraded. SQS would pick up and post that event, and then the data would be there. The same would occur as sort of user profile retrieval, right? There was points within each layer. So how do we scale? So it's basically very tight plan in advance scaling plans, right? So do we have a user experience latency as measured, through the load balancer, add E nodes? Yes, we're going to time out on writes, but we could have a congestion error, we could have an ELB error, we could have all sorts of things other than just a node failure. We don't want to immediately fail out the node because we're expecting to be hammered on traffic. So let's route it to SQS first. They monitoring CPU, over 70% add E nodes, D nodes more expensive, and then of course we were handling the intermediate failure. The results were pretty spectacular. This was considered absolute breakaway success. I think NBC had done 150 apps that weren't particularly well received. This was broadly received. User engagement was massive. People spent hours in this app. It was #1 in the App Store, long time. Engagement's way up. Mike Martin is no longer SVP of NBC Digital because he's the global head of digital for Nike. It's probably regarded as one of the best second screen experiences. So I think part of that is started with incredibly compelling content, right? The 40 years of SNL content and the metadata work. But from the ops standpoint, I think there's some key lessons here. The constrained scope really helped, right? They weren't doing too many things at a time. They had a focus on create binge watching experience for these 5,500 clips. And that really helped set an agenda. They decomposed into services, had metrics and monitoring from day one. They're mom and apple pie stuff, but they kept it clear throughout. There wasn't a lot of scope changes. There was a lot of work on the ops book. There was definitely much more time invested on preparing for failure than automating or building out, right? That was significant time on that. I think One of the ways that paid off, though, is they also spent time by leveraging scalable services, not building around what to do if the service doesn't scale, right? That can be a real-time sync. It can be a scope nightmare. You end up with a whole other code line and sort of functional test loop because of the code to deal with what happens if it doesn't work. And mostly they've just focused on building scalable services. They had some failure cliffs that eased off that pressure. And they use scope control to really isolate the unknown behaviors, right? So they know what it takes to stream behavior. They know what it takes to maintain a session. There are things that are known, and then the recommendation engine was unknown. So isolate it, make sure it's scalable, make it idempotent. Scale up was far easier. This was a lot of testing about scale up versus scale out. And it was really, when you're being crushed with traffic, it is a nightmare to switch the users over and switch the user context, and just waiting until the user's done on the smaller instances. Scaling out worked very, very well. You just need to you can use the smaller instances, just make sure they have enough network bandwidth so you don't top out there. The single region, we talked about it there. And I think the last lesson was, no matter how much you think, I've modeled the user behavior, I've got the top end, then double it again, because they had gone through all of that. The show went long, and at the end of the East Coast and the beginning of the West Coast feed, they ran ads for the app, they spiked in users, and those both happened at the same time. They weren't supposed to overlap. The show went half an hour long. And so the app was more successful than they thought, the user engagement was higher, the download rate was higher, and then they got basically double their peak. But they went through the operational processes, they scaled up, I think 4x, scaled back down the next day. This is still, it's used today, it's a fantastic app, it'll suck your time. They put all the new episodes on it, it's a continuous engine. And I'll be, for Q&A, I'll be around. I'd love to tell you about MarkLogic and how it's the most wonderful database ever. We're also at booth 2117 at the reception tonight. Thank you.
Thank you, Aaron, for that. That was definitely interesting to see how MarkLogic actually use AWS for their applications. So my name is Anand Vigela. I'm actually a product manager at FileMaker Inc. FileMaker is a company that's based in Santa Clara. We have about 350 people worldwide at the moment. And what's amazing is we've actually been around for 30 years. And what we do is we allow our customers and our partners to develop custom apps. These custom apps can run on desktop, mobile, and web. But what they also need to do is share these custom apps among work groups. And there's two ways they can actually share these custom apps. The first way that we've been offering for 30 years is an on-premise server, both for Mac and for Windows. And that's been there, people use that, and people love that. But we've always had a desire to have our own cloud offering. And in fact, 8 weeks ago, and I'm not lying here, 8 weeks ago, September the 27th, we actually launched our FileMaker Cloud product offering running on AWS Marketplace. And what I'm going to do is I'm going to walk you through a use case of a specific customer, as well as some other examples about the journey to move to FileMaker Cloud to AWS Marketplace. So first of all, I'm going to talk about a specific auto manufacturer that we work with. They've been a long-time FileMaker customer. In fact, all their installed base until a couple of weeks ago was running FileMaker Server in-house through their IT organization. And we briefed them on our cloud offering as we were developing it. And when we briefed them, they said, hey, we would love to participate in a test program. So the last 2 weeks before we launched FileMaker Cloud, they actually came into our test program. Now, we're a very secretive company, unfortunately, and we don't disclose any timelines to release our product. So they had no idea that in 2 weeks we were going to launch. But then a day before we launched, we gave them a call and we said, by the way, we wanted you to know we are going to officially launch on September the 27th on AWS Marketplace. And that day, they actually purchased our product and an instance and started developing on it. 2 weeks later, they actually went to market with their first mission-critical app running in the cloud. And this was a huge excitement for them. It was excitement because today, it takes them quite a bit of time just to deploy a traditional on-premise server. That was their first problem. The second problem they have is scalability. One of our product offerings that you can build that custom app on is web. But that's very resource hungry. And based on the architecture that they had on-premise, they would have to swap that out. So cloud was a big desire for them. Now, they actually tried to move to the cloud a couple of years ago. They actually did that with our Windows server. Now remember, this server was designed about 25, 30 years ago, and it was always designed to run on-premise. Cloud didn't really exist at that point. We're very new to the game. And what you can see from the architecture diagram on the left-hand side is we have a Windows operating system. We then have a database engine, which is our business logic that runs in there. We have then custom web publishing, as well as ESS adapters. And then our clients are FileMaker Pro, FileMaker Go, and WebDirect as connectivity paths. And then at the bottom, you basically see the data that resides for that customer or that partner that's operating. What you can see is there's one big box around this particular diagram. Basically, when people try to take this server and deploy it to the cloud, yes, it's in the cloud, but they can't maximize all the benefits cloud computing brings to the table, such as EC2 scalability, or even upgrading a simple aspect of S3 or EBS storage. So what it really means is they're going through the process of purchasing Windows EC2, deploying FileMaker Server, and doing all that configuration over and over again. And that process itself can take anywhere from 4 to 6 hours, dependent on the skill set. So they tried to take this product and take it to the cloud, but it still didn't resolve their idea of getting speedy deployments as well as scalability. And they were very reliant on their IT organization. The other aspect is, I'm talking specifically about an auto manufacturer here that's been a long-time customer and has its own IT organization. But we have a number of customers that are in the small to medium-sized scale. These people don't even have IT organizations. They typically have a developer who's wearing multiple hats. They're a developer as well as the IT administrator. So when you try to take a Windows server over to AWS, you have to go through all these configuration settings, group security settings, which are way above those people's heads. So that was another problem we started looking at. And that's where we came up with FileMaker Cloud. Now, what we did here was we really simplified the setup process itself. And we leveraged CloudFormation with that. We worked with a solution architect, as well as best practices and talking to other customers that were in a similar paradigm to us. What CloudFormation allowed us to do was that we could set all the parameters down to security groups, EC2 settings, as well as EBS volumes that get attached. So for the person who's deploying this, it's a click, 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 deploy, as simple as that. We also focused on around simple email service, better known as SES. When you look at our traditional FileMaker on-premise server, the customer or the IT administrator has to also deploy a mail server as well. So we really wanted to simplify our architecture and just use as many of the components that AWS offers that we could actually leverage. So SES was a great path forward, and it's easily integrated. In fact, one of the things we ran into as we built the product and we started early testing, when we didn't even use SES, we were just using a regular mail server that we've used for a long time, is in 3 weeks, or actually 3 days, that mail server got compromised on AWS. That shows that there are opportunities out there. But as soon as we learned about SES and we transitioned to that, it gave us security and peace of mind. The other thing we actually looked at was now tackling how are we going to separate the configuration of the operating system as well as the customer's data. This is now where we call it separate configuration and data. We introduced new EBS volumes. That meant that if the customer or the partner decided to upgrade their EC2 or downgrade it or upgrade storage, their data configuration gets all intact. Nothing gets damaged there. The only area that gets affected is the operating system and the FileMaker component. But that process actually just takes 10 minutes. So they could upgrade, downgrade. So what problems did we actually solve? Well, what I started off by was telling you that this specific auto manufacturer had a problem around deployment. In fact, their deployment for an on-premise server was 90 days. That's 25% of a calendar year. That's crazy. So now, with FileMaker Cloud, what they were able to do, running on AWS and CloudFormation, is they were able to deploy in 20 minutes, a fractional of the time. This was a huge productivity gain for them, and it really then allowed them to go and focus more on actually building custom apps and deploying it. The second issue this customer was facing was scalability. That web direct example that I talked about. What that basically meant was either they had to go and swap out their existing hardware to maintain, or they transitioned to FileMaker Cloud. Now with a click of a button, they can upgrade or they can downgrade their EC2 instance. And that happens in less than 10 minutes. The final thing that we introduced as well was, remember, this is a long-time FileMaker customer. They already have licenses with us, as well as existing customers that we have. So one thing that really excited us about AWS Marketplace was the ability to offer bring your own license. This really meant the customer is only now purchasing EC2 as well as other AWS services. It's a simple transaction from them to move from on-premise over to the cloud, but maintain the license that they've already purchased from us as well. So I'm going to show you a quick demo of FileMaker Cloud through AWS Marketplace. I'm going to be around, so if people want to see the demo, give me a shout. Very quick, I can walk you through it at the moment. Very quick, you simply go to AWS Marketplace. You search for FileMaker Cloud, and you'll actually see 5 product listings. A 5 user, a 10 user, 25 user, 100 user, and bring your own license. And for the very first time as a company, we actually offered hourly subscription. We don't do that at all. But with AWS Marketplace, we wanted to take advantage of that. So now we have hourly and annual subscription of FileMaker Cloud. Now, once you select one of the products, let's say a 5 user, you simply click on continue. You then accept the software terms. And then you come to a page where you click on usage instructions. And we put in there 2 links for 2 data centers, one in US East, one in US West. We're rolling out to EMEA, APAC, and Japan later this year, or early part of next year. So for now, it's 2 US data centers. The customer or the partner simply selects the closest data center to them. When they click that, it now starts a stack creation process, and it's a 4-step process. All they need to do on the first page is basically enter their server name or stack name, their email address, and a key pair, and they click Next. On the next page, they specify their EC2 instance, which one they want to run. On the third page, it's an options page. They specify tagging, just to find the instance easier. And on the final page, they basically just review all the setups, and they click on Next. At that point, the stack is actually being created, and that process takes about 9 to 10 minutes. We then send them an email. When we send them that email, they now specify a host name and a password, and then they're fully deployed. It's as simple as that, and we really did that to make sure we can go and attract customers that are not only small to medium size, but also higher end customers. Because the benefit of CloudFormation is they can tweak based on their settings as well. So apologies, I couldn't demo that, but that was a high-level walkthrough. So what are some of the lessons we've learned from this process? The first one we've learned is when we built this product and we deployed it, we started using EBS, Elastic Block Storage. EBS has been around for quite some time, but it's reliable and it's robust. And we wanted to build something that can get us out the gate and enhance it over time. Our future direction is to leverage S3. It's cheaper, it's faster, and there's no limitation on how much you can actually use to store. So that's a future direction that we're starting to head into. The next one is SES, and I touched on this earlier. We are really looking at ways that we can leverage other AWS services that make it easier for us, as well as for our customers. SES was a perfect example, and it's very, very easy and straightforward to set up. So here's a summary of AWS Marketplace itself. This is Justin's slide, but use Marketplace to accelerate, evaluate, and deploy data management. You can understand storage, read and write throughput requirements as well, and then follow AWS best practices. You can test your applications to a scale, as well as review and implement DR. And finally, enable monitoring, including CloudWatch. So we've got about 15 minutes. Aaron and I are more than happy to take any questions. There's some mics on either side of the room here. So feel free to ask any questions you have. We're still going to be around, and as Aaron mentioned, MarkLogic also have a booth available. So jump in, guys and girls. There's mics right there, sir.